In this lesson, we're discussing rational approximation. By the end of the lesson, you should be able to identify a rational number and find the rational approximation of a square root. Rational numbers are numbers that can be expressed as a fraction. So integers, I can change that to a fraction just by writing it over 1. Fractions, and then decimals, but only the ones that terminate a repeat, because those are the ones that I can change into a fraction. Rational approximation just means that we're going to estimate the square root and we want to get it close to a rational number. So between what two perfect squares? And then we use a decimal to indicate which one it's closer to. So for example, the square root of 60, that is not a perfect square. But I can see that 60 is right here in between these two perfect squares of 49 and 64. So my answer will be, it's between 7 and 8. It's a little closer to 8, so I'm going to estimate, I'm going to give an approximation of 7.8. So let's do a few more. Approximate each irrational number and identify the consecutive numbers it lies between. So the square root of 14 is here between the square root of 9 and the square root of 16, maybe closer to the 4. So it's between 3 and 4, so I'm going to estimate it to be 3.7. All right, square root of 44. That is between, right here, between 36 and 49. So it's between 6 and 7, and it's pretty close to the middle, but maybe I'll go 6.6. And the square root of 99, that's over here, between the perfect squares of 81 and 100, but closer to the 10. So it's between 9 and 10, but I'm going to go with 9.9. So here we're going to approximate the irrational number and plot it on the number line. So we have the same thing. The square root of 17 is between two perfect squares of 16 and 25. So it's going to be right there between the 4 and 5, but much closer to the 4. The square root of 39, that's going to be between the perfect squares of 36 and 49, so right in here, but again closer to the 6. The square root of 88, that's going to be between the two perfect squares of 81 and 100, but closer to the 81. Move the square root to approximately where it belongs on the number line. So the square root of 2 is going to be right over here, a little more than the 1, because 1 times 1 is 1, but not up to the 2, because 2 times 2 is 4. Negative square root of 7, well, that's going to be over here in the negatives, and it's going to be between the 2 and the 3, because it's between 4, perfect square of 4, and the perfect square of 9. The square root of 20 is over here between 4 and 5, because the square root of 4, or the 4 squared is 16, and 5 squared is 25. The square root of negative 30 is going to be over here, about there, because it's going to be between 25 and 36. The square root of 57 is over here, between the 7 and 8, because it's between 49 and 64. Negative square root of 84, that's going to be over here because it's between the 9 and 10, but closer to the 9. And then the square root of 99 is almost the perfect square of 100, so I'm going to put it right there between the 99 and between the 9 and 10, but closer to 10. All right, so what is a rational number? It can be written as a fraction. So rational numbers include integers, decimals, and fractions. What is the rational approximation of the square root of 39? Well, it's going to be between the two perfect squares of 36 and 49, so it's going to be between 6 and 7.